Hello everyone, my name is MEDIANADIR and my presentation for today is going to be about paper substrates for printed electronics. On this presentation, we're going to go over about what is the printed electronics and the type of printed electronics, how to select the base substrate paper, and we go over about what are advantages of using a paper as a substrate and what's its applications, and what is the problems faced by paper, and the transistor built on paper, fabrication, and we're going to go over the results after the fabrication and what is going to be the conclusion. Printed electronics are used in more products today than ever before. As technology continues to advance and inkjet printers become more capable of printing electrical circuits faster and at lower cost, product designers and engineers rely on printed electronics for flexible screens, intelligent labels, and packaging, OLEDs, medical devices, wearables, and other products. But it can be just a challenge to choose the right printed electronics for your product as it is to design and develop a product itself. There are 5 different types of printed electronics. Starting from first one is the roll-to-roll, which is roll-to-roll processing of creating electronic devices on a roll of a flexible substrate paper. The second one is the sheet-to-sheet. It is same as roll-to-roll processing, but using separate sheets. This is mostly used for low volume. Third one is a flexographic, where the final pattern stands out from the ink transform. Fourth one, graver, is the reverse process of flexography, where image used to printed in is negative. And the fifth one is the offset type. And this slide shows the different types of the printed electronics, which is the roll-to-roll, and how is the difference from the sheet-to-sheet. So we can see here that the printed paper is going all the way on the printing machine, which is a one roll. And if we go to the sheet-to-sheet picture, we can see there it's a different rolls and a different printed process. So now the question is how to select the better substrates. The decision between types of substrates, whether it is paper, plastic film, metal, or other, is critical in design of a printed electronic system. Each of these substrates has its advantages and its disadvantages. Whether one selects polyethylene, the other selects polyethylene naphthalate, the other select polyimide, paper, foil, or some other substrate. The performance characteristics of the substrate will impact the application. As an advantage of the paper substrate, the solution process has gained widespread attention over the past years due to their potential low-cost advantage in terms of fabrication of electronics as well as application to the flexible electronics, which makes substrate paper the most attractive attributes among the other glass or plastic. Also, it acts as a good insulator and biodegradable. In our life, printed electronics are being used to form flexible keyboards, antennas, electric skin patches, and more. It is one of the fastest growing technologies today and has become invaluable to several industries, including healthcare, aerospace, media, and transit. On this slide, we can take a look to different applications today and how the printed electronics paper used in same applications in future. In the previous slides, we will talk about the substrate paper advantage and their application. But how about the problems faced by paper? When it comes to substrates, the most important characteristics are smoothness and wettability. Some substrates can be prepared for better suitabilities using pre-treatments such as coating or corona discharge. Highly absorbent substrates such as paper are not typically suitable for printed electronics applications. Since the maximum fabrication temperature was limited to approximately 100 degrees, so using a paper substrate facing temperatures restrictions. On this slide, we can see a single transistor printed on a piece of paper substrate, which has all the transistor details preparing like layers. We can see the gates, the dielectric, the drain, the source, and that's how could the paper substrates have the transistor printed. Fabrication process. Cyclopentasiline is used for solution-based processing of silicon. As a liquid, the material has the potential to be applied directly on a low-cost, flexible substrate that generally have a low thermal budget by annealing the liquid using excimer laser treatment. So far, electronics based on this material have only been demonstrated on rich and high-cost substrates. In this work, silicon has been applied as a solution on top of the paper substrate and processed into PMOS and NMOS, thin film transistor. As experiment was carried out were in thin film transistors. So the following steps were carried out. It will be 8 steps, starting with cyclopentasiline coating, local excimer laser, low temperature oxide deposition, shadow mask gate evaporation, self-aligned ion implementation, laser dopant activation, shadow mask oxide etching, and the last step is the shadow mask contact evaporation. So on this slide we can see the fabrication process. So the first part shows the fabrication steps and the second shows the transistor parts in details on a paper after printed. And we can see at the third part it shows the number of multiple transistors are fabricated on a piece of substrate paper. By looking to the result of the printing process, with respect to the charge carrier mobility, NMOS shows lower mobility than PMOS and a high leakage current to reach 10 to the minus 9 AMP observed of PMOS as a result of the diffraction oxide from the sample heating by an implementation of NMOS. And for leakage current, we can see that NMOS is better in terms of observation than PMOS. As a conclusion, we can assume that the printed electronics aid in making everyday objects smart, from antennas and sensors to displays and printed batteries. Printed electronics are being integrated into paper, plastic film, fabric, metal, and 3D printed objects. As well as paper has potential to extend the reach of electronics into area we might never have considered before, offering customers a much wider range of choices when it comes to performance, reliability, and price. At the end, I want to thank you and wish you had an interesting information.